Linear in the sense one by one. So you will be storing the data one by one or sequentially. So that is what I will call it as a linear. Useful is a function which will help me to check whether my stack is full or not. Peak will give you the element which is in the top. Hello everyone, I welcome all of you to the very interesting session on stack. So guys, in the beginning session, I had given you an introduction about the stacks, but that was not sufficient. Yes, I'm going according to the syllabus. Now it's time for all of us to understand in detail about the stacks. So let's check what do I have in this session for all of you. So guys, in this session, I will be discussing what exactly the stack is all about. I mean to say the definition of the stack. Along with that, I will also discuss some of the different operations that I can perform with respect to the stacks. So this is going to be the agenda for the day. So let's start. So guys, stack is a linear data structure. Sir, what is the meaning of linear data structure? You all know that linear in the sense one by one. So you will be storing the data one by one or sequentially. So that is what I will call it as a linear. So fine, you all know that we have discussed in detail what exactly the data structure is all about. Organizing the data. So fine, then what did you understood by this linear data structure? You are trying to organize the data in the linear fashion, one by one. So that's what I will call it as a linear data structure. So fine. So even stack will also comes to that particular category. Fine. So I understood the first point. The next point which you need to remember now. So what is that? So it's a very important point with respect to the stack. So what is that? Which follows the particular order in which operations are performed. The order may be LIFO. What is the meaning of it? LIFO. So last in, first out. What is the meaning of it, sir? Last in, first out. Observe here. So this is what I will call it as a stack. Okay. So if I want to insert anything, so I will insert it. Okay. So first this one I'm trying to insert, it will come and sit here. Okay. So next I will insert 2. All right. So this 2 is going to come and sit above the 1. So that is what you need to observe. All right. Now observe what I'm trying to do is, if I want to remove this 1, how do I need to remove? I need to remove this 2 first and then I have to remove the 1. So what is the meaning of it? Please observe last in, first out. So this 2 came in the last, so it is going first. So in the same way, I can also call it as first in, last out. 1 came first and it is going last. So this is the fashion or the principle that I follow in the stack. So this is the basic thing that you need to remember. So guys, you need to observe here I have mentioned this as an empty stack. What is this? Empty stack. I don't have anything in this stack. Okay. If I want to insert any element inside this stack, okay. So observe, I'm trying to insert this element inside this stack. So which operation I have to perform? I have to perform the operation called push. I have to perform the operation called push. That's what you need to remember. In the same way, if I want to remove, okay, I will be using the pop operation. So when I'm performing the pop operation, so what is that I need to remember? How do I perform the pop operation? All those things I will discuss in detail in the coming slides in detail. As of now, you just have to remember what is stack, how do I insert the element, how do I remove the element, and what is the definition. This is what you should know before I move to the next topic. Hope it is clear to all of you. Moving forward to the next one, stack operations. As I told you, I can perform push and I can perform pop. In the same way, I have some of the operations which I can perform with a stack. My dear students, this is going to be very important with respect to the exam point of view. You might get a question, mention the operations which you perform on the stack. What is that we have? So let's understand and discuss one by one. The first one that I have here is all about the push. It's all very simple. What we have discussed earlier, push in the sense you are trying to insert an element inside the stack. So that's what I will call it as a push operation. Do you all remember something called pushpa? Right? So push pop. Okay, so that's what you need to remember. Push in the sense you are trying to insert an element into the stack. In the same way, pop in the sense you are removing an element from the stack. That's what I will call it as a pop. Okay, so fine. In the same way, I have the third operation. What is that? So please observe, I have peek. The meaning of peek gets the top data or the element that I have in the stack. What is the meaning of it, sir? So observe, if I perform the peek operation, so that peek operation will give me the element which is in the top. Top in the sense, what is the element that I have in the top now? So 2 is in the top. So I will get the 2 as a data if I perform this peek. That's what you need to remember. All right. So how do I get the top element which is in the stack? So with the help of this peek. The next one that I have is full. Is it full or is full? Is full. Is full is a function which will help me to check whether my stack is full or not. So full or not in the sense, how do you check? Say for example, you have a bike and you have a tank for that bike. How do you check the fuel is full or not? So you'll open the tank. If the petrol is still, you have the petrol till the top. Okay. So then you will say that the tank is full. In the same way, if you have the data element till the top, okay, so then you will call that stack as full. And the same way, I will use one more function that is empty. So to check my stack is empty or not, I will be using this function. So is empty in the sense what, sir? So I will be checking whether do I have any elements in the stack or not. So for that, I will be using this function. Very simple to understand, very simple to remember. That's what you need to remember with respect to the stack operations. Moving forward to the next topic that I have. Let me discuss this in detail. Now, sir, you said push in the sense you are trying to insert an element into the stack. That's what you told, right? Is it so simple for me to just insert an element? No, I have to follow some certain steps or certain methods. So what is that? Let's understand that in detail now. So guys, first step, before I perform the insertion into the stack, the first thing that I need to check is check if the stack is full or not. Because if the stack is full, then how do I insert? So that is not possible. So the first thing that I need to check whether the stack is full or not, that is the first thing that I should check. So fine. After that, if the stack is full, produce an error saying that an exit. So suppose when I check the stack, if the stack is full, so I have to say that there is no space inside the stack, and then you come out of that insertion operation. That's what you need to do. So that is the first thing that you need to remember. If the stack is not full, increment the top point to the next empty space. What is the meaning of it, sir? You did not discuss this. You need to remember, whenever I insert any element, say for example, this is a beautiful stack, which I'm going to write now. Okay, so what is this beautiful stack? There is something called top. Okay, what is that top, sir? Say for example, I have one here. Okay, so this one is pointed by the pointer called top. So what is this pointer? This pointer always points to the top element of the stack. Always points to the top element of the stack. Now this is the state of my stack. Now I need to perform the push operation. I have checked the stack is full or not. So the stack is not full. So what is the next thing that I have to do? I have to increment this top. Okay. So what is that I will do? I have to increment the top to the next location. So my top is in the next location. And then now I will insert the next item. So that is what they're trying to say here. Okay. My top got incremented to the next free location. So fine. The next step adds the data into the stack that we have already done and returns success. You just have to send a message that data inserted successfully to the stack. So this is how I insert the element into the stack, that is push operation. Now can you all tell me one more time, how do I perform push operation? So first I have to check whether the stack is full or not. So if the stack is full, so what do? I will just say send a message saying that stack is full, cannot insert the data. Suppose if the stack is not full, so what do? I will increment the top pointer and I will insert the data. This is how I will be performing the push operation. So hope all of you understood the push operation. Moving forward to the next one, pop. What is that I have? Pop. Yeah, it sounds really, amazing. Pop operation will help me to remove an element from the stack. So it is just a reverse way of what we have done in the last slide. So what is that we have to do here? Guys, check if the stack is empty. So why do I check, sir? Main purpose of pop is to delete an element from the stack, but I should make sure an element is there inside the stack. First of all, if you don't have any element inside the stack, then what do you delete, right? So first thing, you have to check. What is that you will do? You have to check if the stack is empty. Suppose if the stack is empty, you cannot perform the pop operation. That's what the second point says. Then let's go to the next point. Imagine there is an element inside the stack. So what do I do now? So let's check. If the stack is not empty, it means to say that there is an element. So access the data item at which the top is pointing. So remember, you can delete or you can remove an element from the stack which is pointing or in which the pointer, that is top pointer, is pointing to that particular element. So what is the meaning of it? Observe here, I have the stack, okay? So can you all tell me which element can I remove from this stack? Obviously this. Why? Because my top pointer is pointing to this. You all know what is the principle that I follow in stack. So last in, first out, right? So this is the last in. So first out should be E. So this is what you need to remember. All right, so fine. So access the data that pointing to the top is pointing. All right, so fine. Top is pointing to E. So then decrease the value of the top by 1. So this top will come to this. Automatically the data will be removed. So then send a return message. So now what is that you will do? Again, I need to perform one more time push operation. Is it pop or push? Pop or push? Come on, tell me. So it should be pop. Now if I want to remove anything, it should be pop. So fine. How do I remove? So guys, imagine my top pointer is here. So how do I remove? So if I remove, which element will go? Obviously D will go. So my top pointer will get decremented and it will come to this location. This is how I perform the pop operation. That's what you need to remember at this point of time. Hope the push and pop is very simple for all of you to understand. All right, moving forward to the next slide. I've taken some of the snippet to explain the peak operation so that now you will understand the program snippet also along with this. Guys, I've already explained about what exactly peak is all about. Peak will give you the element which is in the top, right? How do I get that element? How do I perform this peak operation? So observe. So what is this? Int. Int is a return type. Okay. So what is this peak? Peak is a function name. What is peak? Peak is a function name. That's what you need to remember. All right. So fine. After that, I've tried to open the flower bracket. So here your function opens and then I'm using the return statement. I'm using the return statement. So here the name of the stack and I'm passing the top. I'm passing the top. So what exactly I have in the top of this stack, that value will be returned. Sir, you have written stack of top. We're not understanding this. Okay, let me take an example and I'll explain. Imagine I have an array. Okay, so the name of the array is A. All right, so fine, this is an array. So fine, I have 10, 20, 30, 40. Okay, so how do you access this 10? So you will write A of 0. You'll write A of 0. A of 0 in the sense 10. In the same way, the name of the stack is stack. I've taken it as stack. Okay, so the index of the first location, what we are trying to access is top. Instead of 0, I have top. Okay, so instead of A, I have stack. That's it. Hope you understood this. All right, so fine. In the same way, if you want to access the top element, so I will be using this. So with the help of peak function, that's what you need to remember here. So hope you understood peak function to return the top value that you have in the stack. Moving forward to the next one. So guys, what is the next one that we have? Easeful. Easeful is a function which we have already discussed to check whether my stack is full or not. How do I check? It's very simple. If my top in the sense what are you speaking about top, sir? Could you please tell? Okay, top in the sense it is a pointer. always it points to the top element of the stack. If the top is equal to the maximum size, obviously my stack is full. Correct? That's what I've tried here. All right. So fine. Top is equal to the maximum size. Then return true. If it returns true, then I will be calling it as stack is full. Else return false. False in the sense stack is not full. It's very simple. Okay. I'm just keeping it simple so that you will understand this. Right. So hope I'm making it simple for you to understand. Right. Moving forward to the next one. So guys, observe here. Is empty. I'm just checking my stack is empty or not. Okay, so please observe. If top is equal to minus 1, okay, when it will become 1, guys, my stack will be like this. Okay, so 0, 1, 2, let's imagine like this. This is how my stack look like. Okay, let me name this stack. Okay, so it starts from 0, right? So now, why do I use pointer, that is top pointer, to point the top element? Suppose if I insert, let's imagine 10, okay? So my top pointer should point to this. So my top pointer is equal to 0. Suppose if it is minus 1, then it is below this. So there is no element inside the stack. Then I will call that as a true. If that is true, my stack is empty. Correct? Suppose if my top pointer is having the positive value, then I will not call my stack is empty. That's what you need to remember. So that's what we have here. If the top is equal to minus 1, then I will mention it as true. If it is true, then obviously is empty. In the sense, my stack is empty. If it is false, my stack is not empty. That's what you need to remember at this point of time. So guys, hope this snippet is helping you to understand this function. All right. So guys, this is what I have in this session. So I tried my best to make you understand the basic concepts of stack along with the simple snippets. In the next session, I will also explain a simple program to implement the stack. So keep watching. Happy learning till then. Thank you. Bye-bye.